Every QA job is asking for CICD knowledge nowadays. And the knowledge of CICD is what's going to make you really competitive. It's an awesome thing to know. But even manual testers are expected to understand the concept of CICD these days. So I put it at step 7 of the 8 steps to become a QA automation engineer that I came up with. Hopefully you've been watching the series where I started from step 1, learn Python, all the way here, step 7. Step 6 was learn Docker, right? So why CICD? Because it is one of the most in-demand skills out there. If you go and search for QA automation or SDET job, every single job is going to mention some kind of CICD. There's different tools, but the concept of CICD is one I want to explain here, and I want to explain why you need it. And CICD, the knowledge of CICD is the bridge between automation engineer and SDET, right? That's probably like the first step. Docker, we talked about Docker in the previous video. Docker is a tool for CICD, one of the things you need for CICD. So it sets up the base for everything you're going to do moving forward. So an automation engineer would know how to test the front end, how to test the back end. They would know Selenium, Playwright, and REST API testing with Postman or with a framework. And then that's an automation engineer. Then you want to contribute more to the team, right? You want to be a software engineer. Then the development, the CICD comes in the picture. So that's why CICD, I call it a bridge between automation and SDET. A lot of times SDET and automation are interchangeable. Even when I look for a search for a job, I search for automation engineer because that's the most common term. But if you want to get to the nitty gritty of it, there is a difference between automation engineer and SDET. All right. So as an SDET, you are a critical component of CICD process. So once you understand what CICD is, you understand why as testers are a critical part of that. So what is a CICD process? So the CICD process is the process of you have the code, right? The developer writes the code and the code needs to make it to a final destination, which is a server somewhere where the user uses it. If we're talking about web applications, a lot of my experience is testing web applications like websites, right? Like things like Facebook or CNN.com or Fox.com or any kind of website, right? Amazon.com. Those are web applications. We have a habit of saying websites, but they're like much bigger than that nowadays, right? There are applications, but they're web applications because they run on the web. So if we just talk about that code needs to live in a server somewhere so the public or the clients, us, can access it and we can use it. So the process of taking the code from the developer and putting it all the way onto the server, that is called CI/CD, continuous integration, continuous development. And there's a whole lot of process and there's a lot of different stages. It's not just developer and then the final destination. So as part of the software testing fundamentals course, as a free course, this is the slides from that course. So I'm going to just use those slides to explain a little bit about CI/CD and environments. Environments in the CI/CD world are important. So you have to understand what environments are so you can appreciate a little bit more of CI/CD. So it's a free course, software testing fundamentals. I put the link in the description. You can take it and it has a lot of technical parts and also basic parts in things like this, just explaining how things work. So what are environments, right? When we're talking about environments, any application, let's just use Facebook, because everybody uses Facebook. The Facebook we know, facebook.com, that's a production site. That is where the final destination. Remember I talked about the developer writes it and it gets to the final destination. Facebook.com is the final destination. That is what we use as a Facebook user. So here in this slide, the red one, the production environment, is where the public sees. So by the time the code gets there, it needs to be tested, it works, everything is good to go. It's never perfect, but it should be as clean as possible, right? It's never bug free, but there will be some things, but at least the major ones should be solved before that. So that is an environment, and that just means the code is in the particular server. Normally when we go to facebook.com, we know the name, but the computer just have an IP address, right? We don't want to get into that, but that just means the code was put into that prod environment. But before that, every company could have different things, but it's typical to have like 3 environments. You have a development environment, which is its own server. When we look at this, let's just look at this. So instead of facebook.com, there will be dev.facebook.com. That can be anything. I'm making that up, right? The name can be anything, but that means the code is put into a server that's called a development server, and it's a dev. The public cannot access it. So everything that's in the yellow right here, the public cannot access that. That's internal. Either you have to use a VPN or you have to be in the office where the internet is basically, it's like a private network. It's called a VPC, I believe, virtual private cloud. But anyways, it's isolated so the public cannot access it. If you go to dev.facebook.com, you can't access it unless you use a VPN or something like that. So the code gets put into this server, some tests happen, then there goes another server, some tests happen, then goes to another server, and some minor tests will happen. A lot of times in my experience, this test server, we run regression, all our testing happens there, performance testing and things like that. So the concept of environments, I want you to understand so you can understand CI/CD. So CI/CD is the process. As soon as the developer commits the code, which means like saving the code, Git is part of what you learn in the process. Git is the way we control, we save our code basically. As soon as the developer saves its code, the CI/CD pipeline will take that code and puts it into one of the first servers. Then some things happen, and if everything is good to go, it goes, puts it into the second server, and then the third server. That is the process of CI/CD. So just so you understand what the environments are in CI/CD, because whenever CI/CD comes up, environments come up. To show you a couple of real CI/CD pipelines, I got some of them. This is from, like, you can just take a screenshot of here. This is it's a public repository. It's in my portfolio, one of the major projects in my portfolio. So in the README, I have screenshots of CI/CD because as part of my portfolio, I want to show, yeah, I wrote automation, I wrote code, but I also implemented a CI/CD pipeline, and I did it in 3 different tools. So this one is GitLab Actions or GitLab CI. This is what a CI/CD looks like. So just a bunch of jobs, something happens, and then it goes to the next stage. Something happens, it goes to the next stage. Something happens, it goes to the next stage. And this is a CI/CD in Jenkins. That's the one I'm going to recommend you're going to learn. This is like a more modern Jenkins, right? Something happens, then a bunch of tests run and it gets deployed. There's no deployment in this pipeline. Then this is GitHub Actions. When you look at GitHub Actions, same thing, right? You see how there's different tools. So Jenkins, GitLab CI, GitHub Actions, those are different tools. Here I have a slide about the different tools. Those are the most popular ones. They're not the only one. There's more, but they're different ones. And like you just saw, the real ones, they're very similar. They look pretty much identical, especially GitLab and GitHub. They're like totally different companies, but they look very much the same. So why are we testers or automation engineers, why do we care about that? Because we are a major part of that. If you notice the CI/CD, the process of the code gets written and then the code gets deployed to the final destination. When you look at that process, it needs to be tested in the middle. And who writes the test? Us. That's why we live for, right? We are testers. So in CI/CD, code gets written, code gets deployed, in the middle gets tested. So we are a very critical part of that process. The code needs to be tested before it gets to the final destination. In fact, it gets tested in several places, like we saw in dev and test and staging. So our work, our test, our automation is part of that CI/CD. We can break or make the CI/CD pipeline. That's why as testers, I strongly recommend you learn CI/CD tools. And I'll start with Jenkins. I did a little research and Jenkins is still the top dog. It's one of the oldest ones, but still companies use Jenkins a lot. So I would start with learning Jenkins. So there's difference between Jenkins and GitHub Actions. I don't have GitLab here. It's a different one. I want you to start with Jenkins and go to GitHub Actions. The big difference is Jenkins is self-hosted. It's a software. It's a free software, but you do need to run it. You do need to install it. You can install it on your computer directly. You can use Docker to run it. In my course, in my Jenkins course, we use Docker because it gives you a more realistic environment because Linux is very powerful, very customizable. And again, like I said earlier, high market demand for an SDET. GitHub Actions, the beauty of it is free because in GitHub, and if you already have your code in GitHub, you just create a CI/CD pipeline there. It is part of GitHub. That makes it super easy. But again, the demand, Jenkins is more. So my students, I recommend Jenkins. So YAML syntax, it is the easiest way to get started because you don't have to install it. And the concepts are simple. Just one, like a YouTube video, 1 hour YouTube video will just get you there. Again, this is not something you're going to learn on its own. You got to have some kind of code. You got to have some tests you wrote ahead of time. Step 1, step 2, step 3, up to here. Then come CI/CD, you can implement that, right? That's why I created this exact steps, 8 steps to become an automation engineer, an in-demand automation engineer. In fact, if you follow this, you're going to be better off than most automation engineers out there. All right, how to learn CI/CD. Again, it's just any course will do for this one. Just find any project-based course. If you want to join me, of course, join me. I have CI/CD part of my program. First month is free. At least right now, first month is free. So you can just go in and just check out all the courses. It's a community. You get my support. If you want to do one-on-one coaching, hit me up. There's also a link in the description for one-on-one coaching. Go check it out and you can work with me. I can hold your hand and just help you become a QA automation engineer all the way, right? So, and other than that though, YouTube is okay for this one. Like in Python, right? Selenium, I said YouTube is no good because you really need to focus. It takes longer time. You need more practice. This one, I think it's okay because you just need to get the concepts and you just need to work on the project. Just make sure whatever course you watch on Udemy, on YouTube, whatever, there are projects. That's the most important thing, man, guys. This is not Netflix. You got to do hands-on. All right. So you can learn anywhere. If you have questions, just send it to me. I'm always happy to answer that. And finally, this whole process, this whole roadmap, I call it a roadmap. You can go ahead and download it. The link is in the description. I have 8 steps detailed for you, everything you need to do. You can use it as a check mark, right? You can use it as a checklist that would help you become an SDET, become a QA automation engineer. I have this as a web page, just a page, also downloadable PDF. So if you don't want to download it, you can do that. So check that out and look at the next video. Step 8 is going to be just upskilling. It's not a specific tool. Just keep growing, keep learning. Your learning never ends. I've been doing this for 11 years and I'm still learning new tools. It never ends. And now with AI, that's going to accelerate. We're going to have to to learn a lot more. All right, so there's a video on the screen. Go check out the next one and I'll see you there.